Alright friends, welcome back. In this video I'd like to go ahead and take a look at section 6.3 of your textbook and talk about systems of equations that actually involve 3 variables instead of just 2 like we might be used to. So instead of x and y solely, we are going to have x, y, and z, which means that we have some equations that you can plot in 3 dimensions versus the 2-dimensional xy plane here. So what we're going to do in this video is we're going to take you through 3 examples. These 3 examples are going to be examples of different types of systems that you'll need to be responsible for. So let's go ahead and dive into that, right? So the first type of system that we will see involving 3 variables is going to be one like this, where you can see what they've done in that very last equation is they've just handed you what the value of your third variable is. Okay, so we can see that that last equation just simply says z equals 5. And what this gives us the ability to do is perform this method of what we call back substitution. Okay, and so we'll describe later why it's called that. But let's go ahead and get started here. Because z is equal to 5, that means in all of the other equations, what we can do is substitute in 5 for z. Okay, so we're going to go ahead and go on through here and substitute 5 for z. Z for 5, I meant. Now, you'll see in that second equation what ends up happening, right? In this second equation here, the one that says y plus 2z is equal to 13, if I plug in a 5 for z, you're going to notice here that the only unknown is going to be y in that equation, which means we can go ahead and solve for it. So this will be y plus 10 is equal to 13, which means that y is going to be equal to 3 in that example. Okay, so we actually have our y here as well. We're going to be finished with the problem once we come up with all 3 values for x, y, and z that if we were to plug them back in would make all 3 equations true. Okay, and so we now have our y value, which means we could just go ahead and do that exact same thing. We could plug it in for y in that first equation here, and that will give us the ability to solve for x. So in that first equation we had 2x minus 3 times y, which is 3. Plus 2 times z, which is, or actually that doesn't say 2 times, it just says z, doesn't it? So we'll just plug in a 5 for that, and then we'll just say that that's equal to 10, all right? And now, again, the only thing that we don't know is x, so we're going to just go through and do our usual thing here. So we could say here 2x minus 9 plus 5 is equal to 10. Simplify that down a little bit. 2x minus 4 is equal to 10. We can add 4 to both sides and see here 2x is equal to 14, and then divide both sides by 2. X is going to be equal to 7. And so there we go. So again, you're going to be finished with these problems once you've identified x, y, and z. And the way that I'd like you to go ahead and write your answers, just like we did when we talked about systems involving 2 variables, we wrote an ordered pair. We have 3 variables now, so this is called an ordered triple. Okay, it's basically going to look the exact same way. We're still going to go ahead and write out the coordinates here. Our x coordinate first, our y coordinate after that, and then we're going to go ahead and label down our z coordinate, okay? And so this would be an ordered triple. This would be a point that we could plot in 3 dimensions. If you want some more intuition for how that would look, then go ahead and look in today's Schoology folder. I've included some interactives that will kind of shed some light on how to plot in 3 dimensions. So if you're interested in that, check that out. Part B is very much the exact same type of problem where we have this method of back substitution. And again, the reason that we call it that is because we're given one of our variables and we're allowed to go ahead and plug that back in to find our second one and then plug those back into the first one to get our third variable. So that's why it's called back substitution, is because we're constantly working backwards to plug something in and then getting the rest of the values that we're going to be having. Let's take a look at a different type of example of a system involving 3 variables here. The one that makes this unique is that you'll notice that each one of your equations involves a different pair of variables. The first equation involves x and z, the second equation involves x and y, and the third equation involves x and z. And so it could be a little bit confusing about how to continue here, but what we're basically going to do is we're going to follow the following process, right? We're going to start off with some substitution, and then we're going to end this problem off with some elimination. So really the only thing that makes these problems different is just that there's some more work attached to them. But it's work that we already know how to do. So let's get started with that, right? So we're going to take this first equation right here, and I'm going to start off with that one simply because it's got some smaller numbers in it. It might be a little bit easier to work with. And what I'm going to do there is I'm going to go ahead and isolate one of the variables that I see in that equation, okay? It doesn't matter which one you do. I'm going to go ahead and isolate x here. And the way that I might do that, of course, would be to subtract 2z from both sides, in which case we're going to be getting 2x is equal to 2 minus 2z. And then to solve for x here, to get it isolated, I'm simply going to go through and divide everything by 2, in which case you're going to get this. X is equal to 1 minus z. Okay? And now, again, this is a method that we used to perform in the earlier videos for substitution method. We now know that everywhere we see an x, we could take it out and we can replace it or substitute in its place this expression 1 minus z, which remember we always needed some parentheses around that just in case, right? And so where do I see an x? Well, if I look at the second equation, I see that there's an x after the 5 right there. And so what that gives me the ability to do is take my second equation here and perform that substitution. So we'll say here 5 times x, but playing the role of x, of course, is this expression right here, the 1 minus z. And so we're going to go ahead and substitute that in its place. So 5 times 1 minus z. We're going to say here plus 3y is equal to 13, just writing the rest of that equation there. And now again, this is why we needed those parentheses, remember, is because now we need to remember that we need to do distributive property, which we'll go ahead and perform now. 5 minus 5z plus 3y is equal to 13. And then we're just going to clean this up a little bit. We can bring that 5 over to the other side, combine that with 13. And then on the left-hand side with the remaining terms, I'm just going to go ahead and write this out so that it follows the alphabet. That's convention in math. We're going to write this so that the y term comes first, followed by the z term. So 13 minus 5, of course, is going to make 8, okay? And now we arrive here, right? We kind of hit this, this point now where it's not really clear where to continue, but remember that our system originally involved 3 equations, and so the one that we haven't touched yet is this third one right here, and you may notice that it involves the exact same variables as the equation that we just ended up with here after performing that substitution step. So what we're going to do is we're going to proceed by treating these 2 yellow equations as their own system themselves because they involve the exact same variables here. So I'm just going to go ahead and write one over the other and line them up so we can go ahead and continue with some quick elimination here. So I'm going to write the original equation up there that I was given, and then right underneath it, just so everything's nice and lined up, I'm going to go ahead and write that second equation right underneath there. And you can see here that because they do involve the same variables, this is something that I can perform some elimination with, and again, that's also because the numbers in front of the y's are also the same. So if I were to go through and subtract these 2 equations here, we could see pretty immediately that our y column is going to be the one that gets eliminated if we were to actually go through and perform this. So let's go ahead and get that done, right? Our y's are going to cancel there for us, and then we're just going to subtract all the other columns here. So negative 4 minus negative 5, that's going to give you positive 1z, because remember when you subtract off a negative, it changes to plus, so that's really negative 4 plus 5. And then for the number column here, we have a 4 minus 8, and that is simply going to give us negative 4. And so we end up here with our first one of our 3 variables. We have z is equal to negative 4. And then as we saw in the previous examples, once you get one of your 3 variable values, you can just plug it back in and then get the other 2 really, really easily. Okay. For example, here we have z. Let's just go ahead and pick up with this yellow equation right here. We have 3y minus 5 times z. We know that z is equal to negative 4. So we're just going to simply plug that in, and we're going to solve this equation for y here. So 3y plus 20 is going to be equal to 8, and then subtract 20 from both sides. You're going to get 3y is equal to negative 12, and then divide both sides by 3. We're going to be getting y is equal to negative 4. And so we end up getting the y value that we needed there as well. We only have one more to find. That, of course, is x, and so we're just going to perform that back substitution here. A little bit of an easier way to do that would be to just go back to this substitution equation that we came up with earlier, because this says that if I have the z, it gives me a way to calculate x directly. Okay, so let's go ahead and do that, right? We had that equation before that said x is equal to 1 minus z. Let's just go ahead and plug that in. So x is equal to 1 minus what we got for z, which was negative 1/4. And then we see here that minus negative changes to plus, so that's really 1 plus 4, and that's going to give us a value of 5 for your x coordinate here, okay? And so we are finished with the problem once we go ahead and take our 3 values here and write that out as an ordered triple, which is how I'd always like you to go ahead and write out those answers. And again, this is an ordered triple, so the order just follows the alphabet, x, y, z. So our x value is going to come first, 5, followed by our y value, negative 4, followed by our z value, which is negative 4 as well. So here is our ordered triple there. And again, if you were curious about how you might plot that in 3 dimensions, check out today's Schoology folder for that interactive. Okay? So if you have another example like that where all 3 equations involve different pairs of variables, this would be the way you would want to do that, right? Perform some substitution to start, and then finish off the problem with some elimination, and you'll get the problem done pretty easily. The last example that I want to take a look at is part D here, where you could see that this is pretty different from the other ones that we took a look at today. This just involves 3 equations with x and y and z, and it does not look like one of them has one of our variables solved for, and it looks like all three equations involve all three unknowns here. And so in order to solve this one, what we're going to have to do is perform some elimination a couple of times, okay? What we're going to do is we're going to take our three equations here, and I'm going to simply number them just so we can refer to them a little bit easier. So I'm just going to call them equations 1, 2, and 3. And what we're going to do is we're going to perform some elimination, okay? How we're going to start this is I'm going to perform some elimination choosing two of the three equations that I originally started with. And so you may want to pick some ones that would be easy to do some elimination with. If you were to take a look at these first two equations here, so equations 1 and 2, let's say, for example, then you may notice if you try to match up the columns there, none of them really match. They're not really ready yet for us to be able to go through and perform that elimination step there. But if you notice, z has positive 2z in that first equation, and then it has minus z in that second equation. And so we can go ahead and get these to match up here if we go ahead and multiply that second equation by 2 and distribute that in here. So what we'll do is we'll perform some elimination with equation number 1 and equation number 2. And we're going to multiply that second equation times 2 in order for the elimination to eliminate a variable here for us. And so we're just go ahead and write that out. We don't need to change the first equation at all, so I'm just going to go ahead and copy it down here. 5x minus 3y plus 2z is equal to 3. And then we do need to distribute in a 2 in that second equation here. So be very careful when you do this. Again, mistakes are going to come in when people are not being very careful about distributive property or watching their signs. So just take this one little step at a time. So 2 times 2x is going to give us 4x. 2 times 4y is going to give us plus 8y. 2 times negative z is going to give us negative 2z. And then 2 times 7 is going to give us 14 here. And again, the whole reason for doing that is so that when we go ahead and line up our columns here, we're going to see that if we were to go through and add these equations together, it's going to eliminate our z column for us, which is the exact goal of elimination method. So we're going to eliminate the z's here, and then we're just going to go ahead and add all the other columns. So 5x plus 4x, of course, is going to make 9x. Negative 3 plus 8 is going to give us positive 5y. And then our z's make 0, so I'm not going to write anything there. But for my numbers column, that's going to be 3 plus 14, and that's going to give me 17. Okay? So what we'll do is we're just going to go ahead and hold on to this answer for now, and we're going to come back up here to my system, and what we now need to proceed with is choosing two different equations and performing elimination with them. Okay? And so we already picked elimination with the first two equations. Maybe let's take a look at another pair of equations here, right? So it doesn't matter which other two equations you continue with, we just need to go through and pick one. The other goal that we need to also keep in mind is that we need to perform elimination, but we also need to eliminate the exact same variable as we did when we did our first elimination. Okay, so we eliminated z in our first elimination. We're going to have to do that same exact thing when we perform our second round of elimination here. So let's say you were going to take a look at equations 2 and 3 here, right? Let's see, we would need to go through and eliminate these z's just like we did in round 1. And you can see how the z's relate, right? In equation 3, I've got a 4 in front of it. In equation 2, I've got a negative 1 in front of it. And so this is going to be another example where I'm going to have to go through and multiply that equation here by 4 so that the numbers in front of z are going to match up for me here really nicely. And so we're performing some elimination here with equations 2 and 3. And again, I know it's a little bit of writing here, but the more detail you put down, the more likely it's going to be that you're going to remember what you did later on if you go back and look at this. So I very much recommend that you do that. So we're going to distribute in a 4 into that second equation there. That's going to look like 8x plus 16y minus 4z is equal to 28. And then we're going to follow up that third equation, which doesn't need any fixing at all. We're just going to go ahead and write it down here. X minus 11y plus 4z is equal to 3. Okay? And again, the whole point of doing this was so that our z's would cancel, and that is a goal that you want to go ahead and make sure that you keep up with, is that whatever you eliminated in the first round of elimination, that's going to have to be the same variable that you eliminate in the second round of elimination. So whatever it's going to take to get that done, we're going to see that that works out here for us if we choose to go ahead and add these equations together. And so in each column, let's go ahead and perform that, right? We're going to have here a 9x, and then we have 16 plus negative 11. That's going to give us plus 5y, and then that's going to be equal to 28 plus 3, and that's actually going to give us here 31. Okay? And so we can see here, taking our original system and picking pairs of equations to do elimination with, we arrive at these two equations right here. So we, of course, have your 9x plus 5y equals 17, and then we have 9x plus 5y is equal to 31. Because we went through and we made sure to eliminate the same variable in both rounds of elimination, what you're going to end up seeing here is that we have two equations that both involve the exact same variables. And so what we're going to do is we're going to treat this like its own separate system, and I'm going to solve this with some elimination here, right? So that first equation looks like 9x plus 5y is equal to 17. That other equation looks like 9x plus 5y is equal to 31. And we're going to treat this like its own separate system and solve this using some elimination here. Now you notice that the numbers already match up in my column here, so I can just go ahead and simply subtract. And what that's going to do is it's going to eliminate the x column here for us. But if you notice, it's also, in this problem, going to eliminate our y's here as well, which is kind of an odd thing, right? You might be scratching your head at this point thinking that you might have done something incorrectly here, but we actually haven't done anything incorrectly at all. What we're going to see is that our x and our y column are going to cancel, leaving us with nothing but 0 on the left-hand side. And then on the right-hand side, we simply just have 17 minus 31. And if you were to go ahead and figure that out real quick, that's actually going to give you negative 14. Now, we arrive at this statement here that says 0 is equal to negative 14. In this statement, you're literally telling me that the number 0 is the same number as negative 14, which we know is not true at all. We end up with this nonsense statement. And so because we just kind of went through the natural problem-solving process, and we were able to kind of see that it leads to this point where we have this nonsense statement, then our conclusion is going to be a special conclusion. What this is going to mean is that this process was not fruitful for us at all, and we were kind of doomed from the start. Our conclusion here is basically going to be that this is a system that does not have a solution at all. And that's going to end up happening whenever you go through this problem-solving process and you end up with this this statement that is nonsense. We know that the number 0 is not at all equal to the number negative 14, and so we're going to have to make sure that we remember to tack on that special conclusion on a problem like that. Okay? And so that's going to do it for this video. I just wanted to kind of go through and demonstrate some of the different techniques that we have for solving systems with these methods here. So I hope everything has made sense. If not, feel free to send me a message and let me know. But thank you very much for your attention, and I will speak to you in the next one.